Okay, so we have our traditional lighthouse question. We have a ship traveling. Is this a rather practical situation that is something that could come up in real life? Maybe. Well, for those of us, that'll be ship captains, I guess. But no, yes, this is something that'll happen. Absolutely. So we have 2 points. Call this A and B. And they set up the diagram for you. Here's point P. And we know that those are two right angles right there. And it's 12 degrees and 30 degrees. And it says that A to B is 2 miles. How far is the ship from lighthouse A? So how do you go about doing this? What should you do first? Tell me what you should do first. Fill in the missing angles. Find the angles. Absolutely. So if this is 30, what's angle PB? We'll call this S. What's angle PBS?
60.
Ha, cool, PBS. 60 degrees? Absolutely. Therefore, what's the angle BAS? 78 degrees. Okay, excellent. So what can you do now? Now that you have the angles. What? You can use law of sines. So you know that the sine of... Let someone just tell me what... There's many different ways you could use the law of sines right now. Can someone raise their hand and tell me which specific ratio you want to set up? Sine of what? Someone raise their hand. Victor.
Sine of 42
over 2 is equal to what?
Sine 60
Over what? AS. Exactly, right. So you know that the distance from A to S is going to be what?
2.5.
Well, fine. We won't have to do the middle steps. Does someone have it to 3 decimal places? 2 point what? 5.8 what? How many people agree with that? Excellent. Well, let's go to that. That's fine. 2.589. If you store that, use the store command. So now that you have that distance, we figured part A out. Does that pass the reality test in our head? Yeah, it's not like light years or thousands or fractional or negative, right? Okay, B says, how far is it from lighthouse B? So finding out lighthouse B is just which distance is lighthouse B? S what? SB. Anybody have that decimal for me? Using law of sines, you figured that out? Something different. Someone raise their hand. Walden. How many people got that? 2.924. Nice. Store that as well. You might need it later. Excellent. People agree with that? Yeah, I already asked you that. Wow. 2.924. And then part C asks, how far is the ship from the shore? How do we go about doing that? Yeah, you can use law of sines again. So Victor, what do we use for that?
I just use it like sine of 78.
Yep, exactly. Yep.
Because we know AS.
Yeah. So what is AS? Is AS over what?
No, it's BS over.
I'm sorry. What? Sine of 78 degrees is PS.
Yeah,
PS over what? AS? And do we know AS?
Yeah.
Yeah. So we know that that's equal to PS over 2.589. So what does PS equal? 2.589 times sine of 78. This is where that store command comes in handy. So you rounded your final answer here to 3 decimal places, but when you multiply it by sine 78, if you round before that, you might be off. What does it come out to be? Someone else. What does PS come out to be? What does that distance from shore come out to be? Bruckner, what?
2.532.
How many people got 2.532? Few of you? Okay, that's good. You're popular enough for us to go.
531.
Yeah, again, the rounding can matter if you don't use the store command. If you round in your initial answers, guys, every time on one of these multiple choice questions you find distances like this, what should you use? You should absolutely use the store command. Absolutely use the store command. Yes?
Is it usually rounded to 3 decimal places or 2?
I want you to round your final answers to 3 decimal places. 3. Why? Why 3 decimal places? On the AP exam, it's always 3 decimal places.
Oh, really?
The answer is either exact or 3 decimal places if they allow for that at all in the question. 3 decimal places. If it's not 3 decimal places, you know what the answer is? Wrong. Wrong. People lose a significant amount of points because they do the right work, and then the last point out of 9 on the free response is, is the answer correct? Losing points adds up quick on stuff like that.
So
You want to get
store and you kind of.
what I did in high school is I just wrote out really long decimals. I was overly complete. You could do that, but that's dangerous because you have to type it all out again. You could do it wrong, and that could be worse than rounding. The best thing you do is every time you come up with an answer like that, just store it as a different letter and just remember what it is. Literally on your work, go store A. You'll store B, and then every time you do this, you know that this right here would be A. Do that. That'll be very helpful. Store alpha A. Done. And then anytime you need it, you don't have to do it out. It's much better to do that and not need it than to have to go back and recompute and need it. Okay, let's make the transition now. How are we feeling about FIS 5 law of sines and cosines? How are we feeling about that? How are we feeling? 5 is great. 0 is nothing. We have claw hammer hand. 3, 0. You hate it? You hate it. Okay. Now, how confident are you with your skills using it? 3, 3, 3, 3, 4, 4. Okay, that's not bad. Let's transition to ew, fun, yay. Let's just do this Vista 5 right now. How do you feel about trig identities right now? 5 is they're awesome. 0 is I'm terrible. Let's just do how confident you are with them. 0 is 0 confidence. 5 is I'm really confident. Let me see. What do you got? Pick something and vote. Everybody's got to vote. This is not American. This is not the America semi-participatory democracy. You have to participate. 2, 4, 2, 0, 1. Okay, we're almost flatlined, but some of us are liking it. That's fine. 3. Who found one of these that wants to pick a really good one for us to start off with to examine? Who has a really neat one they want to examine? Denise, which one? What? 14. 14. Before we launch into trig identities, I'm going to ask you one simple question. How many different paths can you generally take to prove a trig identity? Many, many. On any math question, really, how many possible solution methods are there? You can always make it more complicated, right? Add a billion, square it, square root it, subtract a billion, make stuff up. You can go from woo to get to these 2 points, or you can go straight to the point. So on trig identities, that can be the case, but more frequently, you will find multiple ways of doing this. So you're trying to prove the left is equal to the right, or the right is equal to the left. I want you to, right now at least, work on one side. So which side are we going to work on? So we're trying to show that equals 1. Can you touch the other side? Don't touch the other side. What should we do first? Someone raise their hand and give me a very clear idea of what's a good first step. Yeah.
Convert the tangent to convert everything to sine and cosine.
Exactly. That's a great thing to do. That's a great thing to do. So we have 1 plus cosine squared theta over. So what we did there was convert to sine and cosine. You can do that to any of these. That is something you can always do. Sometimes it's not super helpful, but it's a great clarifying move. Now what should we do? Someone raise their hand and tell me, what should I do now? Raise your hand. Someone tell me. Denise, yeah. Yeah, multiply them out. Yeah, exactly. So we end up with 1 plus cosine squared theta over sine squared theta minus cosine squared theta minus what? Cosine to the what power?
4.
To the 4th theta all over sine squared theta. Absolutely. So what did we do there? We multiplied out. Now, what should we do? Someone raise their hand and tell me what you see. There's something really key in there you should see. We have a common denominator, 2 of them. You should see something at this point. Yeah, but the cosine squared theta, they're not tied together. Does anybody see there's a really clear identity in there?
1 plus cosine squared.
Not 1 plus cosine squared.
1 minus.
We know that 1 is equal to sine squared theta plus squared theta, right? So 1 minus cosine squared theta is equal to. So a third step could be apply known identities. So this right here, what does this equal right here? Oh, that's a...
Sine squared theta.
These two together combine to be sine squared. So what do you end up with? Sine squared theta plus cosine squared theta over sine squared theta minus cosine to the 4 theta over theta. Okay, we've eliminated one thing. What should we do now? What? I'm sorry, speak louder.
Put them all together.
Yeah, you could try putting them all together with a common denominator, absolutely. So what's our common denominator going to be? Sine squared. So this is going to be sine to the 4th theta plus cosine squared theta minus cosine to the 4th theta all over what? Sine squared theta. Absolutely, that's great. Well, we ended up collapsing everything because we converted to sine and cosine, we multiplied it out, we applied known identities. What was really the only identity that we applied? Sine squared plus cosine squared is equal to 1. That's really the only identity we applied. We also made sure, another thing I can write down here, what did we do? We factored a whole bunch. By factoring, we created things that we could turn into things like sine squared or 1. Is that helpful? Absolutely. Okay, that's not bad. That was number 14, right? Someone raised their hand, and we'll pick a second one before I send you off. A second one. Yeah, which one? 21. So we have number 21, which is 3 sine squared theta plus 4 cosine squared theta equals 3 plus cosine squared theta. Yeah, you needed 1 plus sine in the numerator. You needed it, so we did it. Oh, look at that. We built it, and it just happened to work nicely. The key step that I think hurts people the most is sometimes they get drawn out into, kids are like, oh, I just got to simplify. And sometimes you do. But unless you've explored all other options, don't multiply out unless you have to, especially since, why should it make you feel pretty nervous to multiply this out? What term do you end up with if you multiply that out?
Cosine, sine.
You end up with cosine sine. In your experience in trig land, when you have cosine times sine or two trig functions like that multiplied together, does it lead you to nice places? Not really. Sometimes it can. You see those in like the double and the summation formulas? Ugh. Blah. Blah. Okay, do you want to try a really fun one? We have the wonderful question. Tan theta minus cotangent theta all over tangent theta. Stop talking. Cotangent theta. We're trying to prove that that equals, oh, plus 1. That's kind of important. Trying to prove that that equals what? So you're really gunning for this to collapse, right? What first step should we take? Someone raise their hand and clearly tell me what type of first step. Covert? No, you're just itching your head. Denise, go. To sine and cosine. Yeah, exactly. That's a great thing to do. Let's try that. So sine theta over cosine theta minus cosine theta over all over. This is a great thing you could try. Plus okay, now what? Now what? Yeah, add the fractions, but if we add the fractions, what do we need? Common denominator. So you know what I'm going to do? I'm going to do this. I'm going to take this. I'm going to move it all over here. I'm going to ask you this question. We're just going to skip a few ugly things. Let's multiply by something. What do you want to multiply by? A form of 1. Can someone tell me what form of 1 we should multiply by? What common denominator are we going to end up with? Yeah, sine theta, cosine theta is going to end up being our common denominator, right? So what happens if we multiply all 4 of those terms by sine, cosine? What happens? What does this term become? What? That becomes sine squared theta. What's the next one become? Minus what? Cosine squared theta over, what does this one become? And what does, different color running out, what's that one become? Plus what? And we have a plus 1 right here. Ah, now you see something really nice. Can someone tell me what you immediately see on the denominator? 1. Yeah, sine squared plus cosine squared is 1. So now you know that sine squared minus cosine squared plus 1. Nice. Well, let's just rearrange this a little bit. Ready? I'm going to take this, and where am I going to put it? Ooh. So now you get sine squared theta plus sine squared theta, because why? This right here is equal to, how many do you have? Bingo! Bingo! There's always an easier way. I bet there's an easier way than this. The magical step, and this is just by experience, this one right here. Multiplying by 1. How many different forms of 1 are there? An infinite number. Why did I choose that one? You have to stop yourself for a second. You would get eventually to here. If you had just created common denominators and added and simplified, you would have gotten to there through this common denominator. So if that's going to be your common denominator, get rid of it. You should recognize that automatically because you've seen situations like this. 1/3 plus 1/2 over 1/6 plus 1/2. Instead of getting a common denominator, what should you multiply both the top and the bottom by? Multiply by 6 over 6. What does it become? 2 plus 3 over 1 plus 5 over 4. Done. Nuke the denominators. So what did we do here? We nuked the denominators. Yes. Yes.
When you have the sine theta, cosine theta, can you just move the cosine down because
Can you just move the cosine down? Which one? We have a lot of sines and cosines
like,
there.
on the top is sine theta over cosine theta?
No, you can't move anything down because there's the minus sign right there.
So when
You have to have one fraction first.
So when you multiply, you could just move them.
Yes, if it was a multiplication, you could move them down. That is correct, but it's not. That minus sign, you cannot do that. You cannot do that. Get rid of the denominators. Get rid of the denominators. Okay, 22. 9 secant squared theta. Thank you. Yeah, 5 tan squared theta. 5 plus.
5 plus 4 secant squared theta.
How should we attack this?
Turn
Turn
everything into
secant to
sine
cosine.
Turn everything in terms of what?
sine.
Yeah, I like doing that. It makes me feel better. So you get 9 times 1 over minus 5 times. Nice. Now what?
Did you still put that towards secant?
No, you can't touch the other side. One side at a time. One side at a time. One side at a time. Now what? Distribute in 9 over cosine squared theta minus 5. Now what?
So that shouldn't be. Oh, no.
Now what?
The common denominators.
Oh, so what do we have here? 9 minus over. Okay, so now what? You can't get rid of sine squared. We can't really get rid of it.
Sine squared theta out of the parentheses.
You can do anything you want, absolutely.
So it will be.
What is 9?
3 squared.
It's also 5 plus 4, right? That's just keep that in mind. What else? What are you saying?
So what I'm saying is, you put sine squared theta out of.
Yep,
the
okay, so let's just write that. So you want to do 9 times 1 over
cosine theta
squared theta like that, minus 5 times 1 over
cosine
square theta times,
sine squared theta.
yep,
And then just distribute property.
distribute it. What can,
9 minus 5.
huh? Careful.
Ah.
You're almost there. Almost there. I mean, what's 9 minus 5?
4.
So you're almost to where you want to be. Hold on, we're going to go with what Justin's saying first.
Still using distributive property.
So distribute now.
Distribute now.
So what do we have? 5 times 1 over cosine squared theta plus.
Oh, honestly, I mean, after distributive, then.
So should I do this, what I'm doing right now?
I don't think that's not-
Minus 5 times
cosine squared.
theta times. Are we almost there? Now what do we have? Did we match what we have? We have this right here, and we have that. So
And then
this,
distributive property.
let's take a look. We need to take a look at this, right?
Yeah.
What can we pull out of both of those?
5 cosine squared.
5 times what? 1 over cosine squared theta. If we do that, what do we end up with? 1 minus.
Sine squared theta.
Ah, what is 1 minus sine squared theta?
You get cosine.
So it's 5 times 1 over cosine squared theta times cosine squared theta, which is 5. So this right here is equal to 5, and we know that this right here is equal to 4 times. So what do we have? 5 and 4 secant squared, which is exactly. This would be a good first draft, and then you need to go back and clean it up. Yes, go.
There's an easy way.
There's much easier way, yes.
Second step.
So right here,
No, that's the
the third one,
yeah.
right here.
The sine.
Yeah, yeah.
You can just
Yeah,
use
what is sine squared?
1 minus cosine.
Oh, yeah.
Yeah, it's much easier. If you do that, everybody, does it collapse pretty quickly? Yeah. If you do the substitution right here, is it going to collapse? Yeah. Essentially, if you always have in your mind sine squared theta plus cosine squared theta is equal to 1, is that going to help you? Have that in your head, have that in your head, have that in your head. Okay.